All right, guys, so this is the video for section 8.3, and in this section, we are analyzing geometric series, okay? So remember, geometric series is when we are multiplying by the same constant. Okay, so think of it as, every term is multiplied by 2, or every term is multiplied by 8. Or you can think of it as every term is multiplied by 1/4. Okay, or divided by 4. Remember, multiplying by 1/4 is the same as dividing by 1/4. Okay, and this constant that we are constantly multiplying by, this is called the common ratio. And we use a little r to put it in its place. Okay, all right, now let's look at example 1 here. It says, tell whether each sequence is geometric. So once again, we know it's geometric when we're multiplying by the same thing. So if we go from 6 to 12, that means we're multiplying by 2. Okay, now from 12 to 24, we are not multiplying by 2. So we can stop there. We don't even have to find what we're multiplying by. We can just simply say, not geometric. Okay, we don't need to do the rest because we know these two are different. Okay, so if we look at B, from 256 to 64, the same thing as divided by 4 or multiplying by 1/4. Okay, from 64 to 16, same thing as multiplying by 1/4 or dividing by 4. This we're multiplying by 1/4, and here we're multiplying by 1/4, okay? So we would say, yes, this is geometric. And I know it doesn't say that we have to write it, but our common ratio, or our little r, is 1/4, okay? We'll need to know that later. All right, so to write a geometric series, we have this rule right here. Okay, and you will have to know this for a test or quiz. You will have to have this memorized. Okay, so whatever term, that's what the N stands for, is the number of term, is given by your A1. And A1, remember, is our first term. And then this R here is our common ratio that we just talked about. So if we have our first term and our common ratio, or if we can find our first term in our common ratio, then we can write the rule for the geometric sequence. All right, so let's look at example 2 now. Okay, so we want to write a rule for each geometric sequence, then find a sub 8. Okay, well, if I look at this, I want to make sure it's a geometric sequence. It says it is, but I want to make sure. So 5 to 15, we're multiplying by 3. We're multiplying by 3 from 15 to 45. 45 times 3 is 135. So our common ratio is 3, and we will need that. We have our first term. Okay, now remember our rules, a sub n equals a sub 1 times r to the n minus 1 power. Okay, so if I plug that in here, I have a sub n equals, well, my a1 is 5, that's given to me. My common ratio is 3 to the n minus 1 power. So here would be my rule. Okay, now after I have my rule, I can find whatever term I need. So like here we want to find the 8th term, so a sub 8. All that means is I'm going to plug 8 in. So 5 times 3 to the 8 minus 1. And guys, these get really, really big, really, really quick. Okay, so if you put this into your calculator, you get a sub 8 equals 10,935. All right, let's look at the second one here. Okay, so from 88 to negative 44, we're multiplying by negative 2. Negative 44 to 22, we're multiplying by negative 2. 22 to negative 11, multiplying by negative 2. So our common ratio is a negative 2. And when our common ratio is a negative, we're going from negative, positive, or positive, negative, negative. Okay, so we have that our first term is 88. Okay, so once again, we're going to use this rule right here. So I can say a sub n equals, well, a1 is 88, times our common ratio, which is negative 2, to the n minus 1 power. Here is my rule. Okay, now to find the 8th term, I can say a sub 8, and remember, all I'm going to do is I'm going to plug in 8 for my n. And when I do that, I get a sub 8 equals negative 11/16. All right, if you feel like you need more practice on the first 2 examples, go ahead and pause this video. Try to work through these 3 monitoring progress questions, and then I will flash up on the screen the answers to them. All right, so hopefully you worked through these monitoring progress, and this is what you should have gotten. So here's the first 2, geometric, not geometric, and then here's the answer to this one. All right, let's turn our attention to number 3. It says one term of a geometric sequence is A4 equals to 12. Okay, and the common ratio is 2. We want to write a rule for our nth term. So remember, a sub n is going to equal a sub 1 times r to the n minus 1 power. Okay, now we're given our r, and we're given a sub 4. Okay, so really all we need to do is find our a1, plug it back into this form, and we'd have our rule. Okay, so let's put in what we know. We know a sub 4. We know when n is 4, maybe I should put this in words. When n is 4, the term is 12. Okay, so that means it all equals 12. R is 2. When our n is 4, so 4 minus 1. Okay, so 12 equals a to the 1 times 2 to the 3rd. Okay, well guys, 2 to the 3rd is just 8. Okay, so to solve for a1, divide by 8, divide by 8. So I get 12 over 8 equals a1, which is 3/2. Okay, so my a1 is 3/2. So now I'm just going to plug it back into here. So any a sub n, so to find any term, I could just use the rule 3/2. My r, once again, is 2 to the n minus 1 power. All right, go ahead and use the example we just did and try to do this one on your own. So go ahead and pause it, try to do this one on your own. If you need to look back to this one, do, and then we'll go over it. All right, so this is what you should have gotten right here. Okay, now I'm guessing most of you that made a mistake here. So remember, just to walk you through it, 2 over 3 to the 4th power is the same thing as 2 to the 4th power over 3 to the 4th. Okay, which is simply 16 over 81. Okay, I'm guessing if you guys made a mistake, that's where you made the mistake. All right, guys, if you got example B incorrect, I highly encourage you to pause this. Go ahead and try to do the monitoring progress. If you got example B correct and you're feeling good, you could probably skip this. But if you need to try it, please do. So go ahead and pause this video, work it out, and then I'll go over it. All right, if you worked it out, this is what you should have gotten here. It's probably quite a bit easier than the second part of example 3. All right, now let's look at example 4 together. Okay, it says 2 terms of a geometric sequence are a sub 2 equals 12 and a sub 5 equals negative 768. Okay, so just like we did with arithmetic, we're going to use these 2 to set up a system of equations. Okay, so we're going to have to solve both for a1 and for r. Okay, so I'm going to go ahead and write a sub n equals a sub 1 times r to the n minus 1. All right. So I'm first going to take my a sub 2 equals 12, so I could write that as 12 equals a sub 1 to the r to the 2 minus 1 power, which works out nicely because this is just r to the first or just r. Okay, now if I take this one, I could say negative 768 is going to equal a sub 1 times r to the 5 minus 1 power, or just negative 768 equals a1 r to the 4th. All right, now say I want to solve for a1. Okay, so I'm going to divide both sides by r here. So I could say 12 over r equals, those go away, a1. Okay, so now I could plug 12 over r in for this a1. So negative 768 equals 12 over r times r to the 4th. Okay, and this reduces to negative 768 equals 12r to the third. R to the fourth over r is just r to the third. Okay, now I want to solve this, so divide by 12, divide by 12. 768 divided by 12 gives me 64, so negative 64 equals r to the third. Okay, to get r by itself, I'm going to cube root that, so cubed root of negative 64. If I put that in my calculator, my r then would be negative 4. Okay, so if my r is negative 4, I can plug it in here. So 12 over negative 4 equals a1. 12 over negative 4 is negative 3. Okay, so now I have my a1 and I have my r, so I can write my rule. A sub n equals a1, which is negative 3, times negative 4 to the n minus 1 power. Here's my final rule. Okay, so I want you to pause this video and I want you to go ahead and work through B on example 4. Use A that we just did as a reference, so go through and do this. Try it on your own and then we'll go over it. All right, so when you worked it out, this is what you should have gotten. All right, if you got B incorrectly, I highly encourage you to pause this and try this one again. If you got it correctly and you're confident, you can probably go past it. But if you need to do it, pause this and try it again, and then we'll go over it real quick. All right, so this is what you should have gotten here. All right, so the last thing we're going to talk about is the sum of a finite geometric series. Now remember, finite means it doesn't go all the way to infinity. There's a start and there's a clear stop, so maybe we're stopping at the 12th term. Okay, and we could always find the sum of a finite geometric series using this equation here. Now, this equation will be given to you on a test or a quiz, but we will not tell you, hey, this is the sum of a finite geometric series. You will have to know what this stands for and when to use it. All right, so let's look at example 5. Okay, so just to go over our formula, which is right here, I'm just going to rewrite that formula. S of n equals a sub 1 times 1 minus r to the n power over 1 minus r. Okay, we will always get our formula from that. Okay, now this is going to be our n here. And remember, this is our r. Okay, so to do this first one, the sum of our first 10 terms, because we're going to the 10th term, is going to equal a sub 1. Now, I can find a sub 1 by just plugging in 1 in for k, so 4 times 3 to the 1 minus 1, or 4 times 3 to the 0 power. Remember, 3 to the 0 power is just 1, so this is 4. So my a sub 1 is 4 times, parentheses, 1 minus r to the n, so 1 minus 3 to the 10th, over 1 minus my r is 3. Okay, now when I put this out, I'm just going to plug this into the calculator just because it's going to be huge because of this. And when I plug it into my calculator, I get the sum of the first 10 numbers is 118096. There you go. And like I said, I just put this into my calculator just like this. All right, really quickly, I want you to go ahead and pause this. Try B on your own. It shouldn't be too bad. It's just plugging it into the formula, and then we'll go over the correct answer. All right, so this is what you should have gotten for part B.